Going on, my physics students? I'm really excited about this class. This class is my baby. I think I've had all of you folks as students. Either currently, I have some of you guys in my Algebra 2 class, or previously, I've had you as former students. And I was obviously teaching you guys different topics, not physics. I'll tell you what, man. I majored in physics. I'm actually getting a master's in physics. And I eat, breathe, and poop this stuff, man. It's just, this is what I'm excited about. So if you thought I was a mediocre teacher before, you're going to find that I'm going to be an awesome teacher in physics, or at least maybe I might make it so hard that maybe you might find me as a horrible teacher in physics, because it's what I'm passionate about. But I'll tell you what, I'm going to be more excited about this topic than anything else from before. It's just because it's what I do. Got it? I was a little bummed on Wednesday when you guys didn't show up for class. I guess, you know what? It's not your fault. I'm not gonna blame you guys too much. I'm going to I'm not gonna burn you guys too much. I'm going to basically assume that was the first day and you guys didn't even know what time the class started. So hey, that's cool. I gave you guys like a little 12-point video so you guys can watch and do and all of that kind of stuff. And here's the thing, man. We've got a bucket of homework. There's like homework assignments almost every darn day. I'm going to tell you officially on the record, turn in everything on time. Okay? You guys got that? Everyone say yes. I agree, Mr. Dalton. I'm going to turn everything in on time. Make sure you guys... Hello? You guys even there? Audio check. Can you guys hear me? No one's responding. The nice thing about having technical or having you here is no technical issues.
So I'll actually be here every Wednesday.
Yeah, that's cool. Can you guys hear me? What up, dude?
I believe he just got into physics class.
You're not in physics,
Yeah,
are you?
I am.
You're in physics?
I just want to talk to her.
Seriously?
Yeah, man.
Yeah, buddy. I'm sorry. I'm so
She's
sorry.
So great.
That was probably super loud. But I just found out that I got maths in as well. I mean, I love all of you guys, but maths is pretty cool too. In my physics class. All right. Anyway, sorry. It must have been really loud on the microphone. Dude, we're gonna have such an awesome class. Let me basically tell you the rundown of what we're gonna do. I am a physics guy. I'm going to teach you guys really deep. I'm going to teach you guys physics deeper than I taught my chemistry class. And Maston can attest to, like, I heard about that chemistry class. It was horrible.
Except for I totally aced the final.
Except for it was actually pretty awesome.
Yeah.
It was horribly awesome.
Of course, I missed that by a year.
Right.
Oh, yeah.
So here's what I'm going to do. I'm going to start physics class assuming you guys know nothing about physics.
Thank you.
And we're going to build off of topics. And I'm going to tell you up front, I am not going to get through a third of what a regular physics class gets through. I'm only going to get through a few topics, but I'm going to get through really deep. I'm going to get really deep. We're going to get really into it. We're going to build here, pass me that Zippies bucket right there. This is my physics cannon, and we are going to use a cannon today. But we're going to design our own cannons in 3 dimensions. So here's my prototype that I have. I'm still building it. Hopefully I'm going to build one of these for each of you, and you guys will be able to use it. And we're going to be using this to study. Physics is going to be freaking amazing. We are going to be starting off. Here's where I'm starting class off. I have the class set up into different kinds of pieces. One type of physics is called conceptual physics. And it's basically what 9th graders take, and they look at it and they say, let's just think about physics.
Physical science.
It would be like doing chemistry without any of the math.
Oh.
Oh, that sucks.
right? Like you
What
can
is
kind of think
chemistry
like,
without math?
huh, I can kind of think about it. That's interesting, but it's not really like this is chemistry,
Yeah.
right? So what I'm going to do is I'm going to do conceptual physics for like a week to kind of get your feet wet, and then we're getting into hardcore physics with the math, that kind of stuff. Ethan, if you're off island, I've designed this class so that all the stuff we do here, you can do at home. I'm going to send you all the stuff you need.
Who's
All right.
in this class?
We got a few people. This is actually the biggest physics class I've taught at this school.
I just so I didn't
Yeah,
have any
no,
physics, so
I'm
it's not.
I'm
it's
stoked
not
on
on
that.
here yet.
That's cool.
it's
All right.
not- where is it?
Ethan, I'm going to make everything so that way you can do it. Okay, now I told you guys we've got a bucket of assignments. They're like every single day.
Yeah.
Turn it in on time. Off the record. You guys ready for it?
Yeah.
I'm pretty cool if you guys don't turn it in on time.
What?
I'll adjust dates. I'll go through. You guys understand what's going on, right?
Sweet.
But I'm just saying, turn it in on time. The reason for this is this. Look, I don't want you guys to get burned by having like classes, like having assignments stacked up on you guys.
Yeah.
So I think at this point, if there are assignments where there are like too many questions, I'll probably go through and just straight up start deleting questions from assignments. And if there's too many, if that's not enough, then I might even delete a few assignments here and there. Don't count on it. I'm still going to make this thing rigorous. I'm going to make you guys work as hard as you guys did, as hard as my chemistry students did this past year. And they worked their tails off. But I'll tell you what,
Yeah, we did.
it was awesomely, like they did a really good job.
It was
So
worth it too.
yeah, it was cool. All right. So let's get into physics and talk about what physics is, what the study is. I'm actually so excited because I really want to tell you guys what we're going to do, what's going to be coming up. All right, let me kind of tell you guys what a preview of what we're going to be doing is. We're going to be using those physics canons, and I'll tell you what your midterm is going to be, or your quarter one final exam is going to be. We're going to set up a simulation with army men all over the place, and you guys are all going to bring in your physics canons that you guys have been studying, and we're going to have a full-on war. And Ethan, if you're online, yours is going to be even cooler, because what we're going to do is you're going to send me all of your data for the cannon, or you know what I'll do is I'll send you the data and you can use my cannon, and then I'll set up like 4 webcams for you to watch the battle, and then also send me the instructions. So basically, you'll be like the
Commander.
the general that's in a different country sending the battle instructions over. That's what physics is going to be. It's going to be so cool, so fun, and it's going to be a lot of work. All right. Kaylin, I'm going to send you an email right after I'm done with class. I'm going to send you an email with which days. I think we have 4 days when I want you guys to come in.
Okay.
I definitely do want you guys to come in, but everything I'm doing here, or everything we're doing on campus, I think that I'm setting it up so that you can do it at home.
Right.
All right. But I do want you guys to hang out, and I do want you guys to come in. There is one change that I want to talk to you guys about, and that's the time schedule.
Okay.
I think that I'm going to make it so that class is going to be every Monday from 2:15
Yeah.
to
3,
like
2:45.
2:55.
Yeah.
2:15 to 2:55 on Mondays. On Wednesdays, so we used to have it from 2:15 to 3:40, right? It used to be this
Really
block
long.
of time.
Yeah.
I'm going to change that to make it earlier and go from 1:30 to 2:55.
Okay.
The reason being is because half of you guys are actually in my algebra class as well, my algebra 2 class. And then for those of you who had chemistry with me last semester, they had to stay in algebra and chemistry for like 4 hours straight. And by the time we were done, their brains were melted. So for those students who have algebra and physics with me, I basically said, well, on Wednesdays, why don't you guys just hang out with me for like 2.5 hours as opposed to 4 hours. That's why I'm moving that around. We cool?
Roger.
Yeah.
So classes are 2 days, Mondays and Wednesdays. On Mondays it's 2:40 or 2:15 to 2:55, and on Wednesdays it's 1:30 to 2:55.
Right.
Got it? And then, Kaylin, you basically here's the gist of it. You come in this Wednesday for a lab, and you come in every other week after that.
Roger.
Make it easy. But I will send you an email with all of these dates. We cool?
2:15.
In fact, I'll put it in the calendar for you.
1:30, 2:50.
All right. Let's start talking about. In fact, I'll be honest with you, I don't need any of this stuff. I'm going to assume that you guys can read conceptual physics, and I'm not really going to go into talking about what they learned in conceptual physics. I think that today I'm just going to wing it because I just feel like I feel like excited to be starting out the class. So I'm going to wing it. You guys tell me if you guys are cool with this kind of stuff. This kind of makes sense to you. We're going to be hitting this stuff a lot in when we talk about computational physics. So we're moving from conceptual physics to computational physics. But I'm going to kind of just say, here's kind of some things I want you guys to know right off the top. All right. The first is this idea of distance. We usually label distance as d. That's the variable that we use for distance. Another variable that we use is this right here, triangle x. Okay, and distance is often measured in, and I'll put it in little brackets right here so that way you know the units of it, in miles, right? Or feet. But then again, those are the two stupid ways of measuring things. So we like to use meters.
Yeah.
If I put an M there, you guys freak out about that, or does that make sense?
Makes
You guys
sense.
know about meters?
Yeah.
All right, good. There is a symbol up here that you guys probably haven't seen before, and that's this triangle.
Yeah.
Right?
Delta. Yeah.
What that triangle is it's actually a delta, D-E-L-T-A. And it's a very simple concept. It's a really easy concept, all right? It just means change in. It just means the difference of. So if I have like 5 and 2, what is my delta of my numbers? 3, right? Because the difference between the two is 5 minus 2. Are we cool? Does that make sense?
Yeah.
So really, all you got to do is, if it's delta x, it just means x final minus x initial.
Oh, yeah.
Okay? This is good because I'm going to start using a lot of these variables, a lot of these symbols, and a lot of times people get really freaked out by all of these things. But just think about it. If it were like a delta t, what is that? Well, that's t final minus t initial.
So the variable doesn't really matter.
Right. This is just saying, like, what is the change in time?
Right.
Time final minus time initial. What's the change in position? Position final minus position initial. Are we cool with that? All right.
Cool.
That was kind of an algebra 2 as well.
What is that?
That was an algebra 2 as well.
This is in algebra 2. This is in chemistry, right? I use delta t.
Yeah, you did.
Right, delta capital T.
Yeah.
That's where the Q equals MC delta T comes from. So this just basically means final minus initial.
Sweet.
Here's something that I'm going to tell you up front, and it might freak you out. But I think that if I tell you up front, it would be all right. This will be probably the last time you see me using a small little I.
Oh, it's 0. Yeah.
I usually use a 0. And I guess for me what that means is, it's like if this were the time, this is the time at the end, the time final, and then this is the time at 0, which basically means that it's the time at the beginning. It's where it started. And usually when I say this, I say x naught. That's what the 0 is. It's like a K-N-O-T. I don't know why. It's, KNOT means zero, but that's what I'm going to say. So when I'm going through these equations, like for example, delta V is equal to V final minus V naught. All right? So don't freak out when I say V naught or something like that.
Okay.
I think that, why do I do it? Well, I think that when I was a kid, I actually used the F and the I. But I think that after a while, when I got into college, everyone started using F and zero. So I just started
Great
adapting
game.
it. So I kind of want you guys to start adapting that idea. Are we cool with that?
Yeah.
It's because F-Zero is one of the best games ever created.
Yeah. All right. So
Nice reference there.
there's your velocity, or there's your distance. I think the next thing I want to talk about is speed.
Just on the topic of F-Zero.
Speed is actually, you could use the variable s. I rarely ever use the variable s.
Okay.
I always like using the variable v
For
for
velocity.
velocity.
yeah.
There we go. Now, velocity is a measurement of is
Speed.
analogous to speed. And do you guys know what the units of velocity is?
Shoot.
All
Distance
right,
and time.
if you had to drive here, you drove here, or you caught the bus here. The bus was moving at how fast?
Miles per hour.
Miles per hour. 50 miles per hour. 4 miles per hour. Distance over time.
Yep.
So your speed in scientific units would be, well, we don't use miles. We use
Meters. So
Meters.
kilometers per hour.
Kilometers.
Oh.
Oh.
and
meters
then
per hour.
the
Second,
time
okay.
we use seconds.
Yeah.
Exactly. Now, if we're talking about moving faster, then we would probably use kilometers per hour or
Right.
something like that, right?
Yeah.
But for the most part, when we're talking about moving things, and we're talking about throwing things specifically, and I think that pretty much this first quarter, all we're going to be talking about is like throwing things and that kind of stuff. Playing football, so think about doing a lot of that kind of stuff. You measure things in about meters per second. That would be a
Right.
good measurement. We cool with that?
Yeah.
So I really want you to get used to the idea of units on this thing, because units is going to be huge. Units in physics to me is more important than units in chemistry, and I made a big deal out of units in chemistry. But here, I'll tell you a secret. You want to know something? I don't make such a big fuss as chemistry does about significant figures.
Oh, thank God.
So when it comes to significant figures, I'm going to give you guys like the number is this, and I'm going to give you a huge range,
That ruined
so that way you guys can
so
get.
many.
So physics is
Sig figs.
cooler than chemistry in that regard, where like I'm not going to be such a stickler about significant figures. I will ask you to get close to the right answer, right? Like if the answer's 10, you can't put 40. It has the right number of zeros. You laugh, but actually that's a thing.
Oh.
Really? What?
Oh no.
The last one is this. I wonder if I should start talking about this. Yeah, all right, fine, I'll do it.
Acceleration.
Ah.
Now, yeah, listen.
Slowly, my
We
physical science
pretty much
is
always abbreviate acceleration as A. Okay?
Yeah.
And
makes sense.
the units of acceleration. Acceleration is a really hard concept for laymen to understand, I think. It's kind of like, you know what one of my pet peeves is? I actually like watching NASCAR. I'm not a big, like, a religious fan. I watch the whole thing. But I enjoy it. If it's on, I'm down, But the thing that pisses me off when the announcers go is to be like, he's moving at a high acceleration.
You can't.
You can totally move at a high acceleration, but that guy's going fast, and he's not going faster. He's going fast, and he's staying fast. So he's moving at no acceleration. Idiot. NASCAR announcer, idiot. He has no acceleration, right?
Yeah.
Acceleration is the change in speed. It's how fast your speed is changing. In fact, if we want to write an equation for it, we could say delta v over delta t.
Yeah.
The
Yeah.
change in
Change in
velocity
Over the change of
divided by
time.
the change in time.
That makes sense.
Does that make sense to you?
I did this in physical science.
The units of acceleration is actually,
Blood vessels.
well, if acceleration is meters, or if velocity is meters per second, right? Time is seconds, right?
Right.
The units of acceleration is meters per second per second.
Yeah. Gravity.
We often
Yeah.
abbreviate that as meters per second squared.
Yep.
There's 2 seconds in the denominator, so it's meters per second squared.
Yep.
Have I lost anybody at this point?
No.
This is pretty
Not-
cool.
Yeah, so
Yeah.
far so good.
This
Okay.
is algebra.
Let's
Yeah.
start talking
For a
about
moment.
where this idea of acceleration came up. It actually, before Galileo, people didn't believe in acceleration. They believed that things moved all at a constant velocity.
Right.
They didn't understand the concept, and I agree with them. I agree with them, but I see where they're coming from, because before Galileo, they didn't have clocks,
Oh,
right?
right.
They didn't have a stopwatch. So how the heck are they going to be calculating the speed of something, or if something is not accelerating? If you're talking about calculating this, all right, without a stopwatch, how long did it take for this thing to drop to the ground? And did it speed up?
For a split second.
It
don't know.
took only a split second to fall to the ground, and it sped up. I have no idea. I can't see it. It moved too fast for me to see it, to determine whether it sped up. You guys see what's going on here?
Yeah.
So here's
You
what's
even know what a split second.
here's what's happening is, and here's the problem, is what kind of clocks do you have? You could use your heart, right? We could do this, right? We could be like, okay, 1, 2, 3, and we could drop something from a really high height, so maybe it would give us more time to count. But here's the problem with that: 1, 2, 3. Oh, there's a pretty girl. Oh, 4, 5, 6, 7, 8, 9. Right? Like, oh, I'm gonna jog. 1, 2, 3, 4, 5, 6. That's not consistent. So what Galileo did is he was in church, and he was like a good Catholic boy. He was looking up at the pendulum while everyone was praying and whatnot, or he was looking up at the chandelier, and he was noticing that thing swings back and forth like that. And then he said, He did a few experiments, and he tried different masses on that thing. He tried, hanging off the chandelier. The whole chandelier story is not true anyway, so I can make up and,
Okay.
and add,
Aw.
embellish however I want.
I wish
He tried hanging off the chandelier, but he found that
Sounded cool.
it still goes in the same amount of time, believe it or not. That's actually an experiment we can do.
Oh, yeah.
The place.
He tried making the chandelier go up high, but it still goes in the same amount of time, believe it or not. It goes
Really?
further. It
Yeah.
just goes,
The pull of gravity.
yeah, it's crazy.
Gravity's
It's
constant.
crazy cool
Can
like
we
that.
can we do that?
Yeah, sure.
Let's do it.
That's an easy experiment. All right. So
With an iron.
what he did was he did
Oh, I
this, and this might even be an experiment that I might do with you guys next week.
Sweet.
I'm trying to figure out the different experiments. I have like too many for me to choose. But what he did, and this was genius, okay? What he did was he said, when I drop something, it falls too fast for me to measure anything.
Yeah.
Because by the time I start my pendulum and I drop something, that thing's done before it goes through a quarter of its trip.
Yeah.
So what he did was he said, I'm going to take something and I'm going to roll it down a inclined plane. I'm going to take a ramp and I'll make a 16-foot ramp. He took a 16-foot ramp and he rolled objects down this thing. And what happens is you still see the motion that it's going through. It's just you see it happening at a slower pace. You see it happen at a slower increments. And so what he did was he kind of diluted gravity by sliding ice cubes down these inclined planes.
Huh.
That's what he did. And then from that, he was able to say, and actually, I'm going to go through this with you guys, probably in quarter 2, exactly how to calculate all of these things. Actually, we might do this. It's fun. You can measure the angle. And by the way, just to let you know, the angle that I always choose is going to be that symbol right there. Is anyone freaked out about that?
No. Let me think.
I'm going to wait online. Are you guys cool with this?
It's a Pokeball.
I'm going to use X. Yeah, it's a Pokeball, but it's also known as theta. All right. That's usually my variable when it comes to measuring angles. So my variable when it comes to measuring the beginning or the initial things, I usually say not. And then also I use theta a lot for
Pikachu.
angles, right? So he measured the angle, and then he said, well, from that, he calculated that gravity is equal to 11 meters per second squared. Turns out that the actual answer is gravity is equal to 9.81 meters per second squared. But pretty freaking amazing.
Yeah. With no knowledge of gravity.
With a clock that goes like this. I just think that that's ridiculously cool. He's the guy who kind of came up with this idea. So here's what he kind of found. He said, all right, I'm going to mark it off here. Now in 1 second, it went this far. Okay? In 2 seconds, I guess if it were going at a constant velocity, it would go this far.
Right.
But it didn't go that far.
Yeah.
It went this far. So he said, wait a second, it was supposed to go this far, but it went that far. In 3 seconds, I guess if it were going constant velocity, it would go this far, but it actually went, even further, like that far. Even further than this difference over here, it went further than that. And then 4 seconds, they thought it would be here, but no, it was actually like way down here. We go. So this is the idea of acceleration. It's the idea of taking something and then what it is it's changing its position, sure, but it's not only changing its position as a function of time, it's actually changing its position, and that's changing. It's accelerating. In fact, if I were to graph this thing on a graph, like let's say X and Y. And for those of you, I think it's Kingston, Ethan, and Caitlin, you had algebra from me. You had algebra?
I've had algebra
You had
too.
algebra from me? Everything? All right, here, watch.
I'm upset that I didn't now.
Instead of making, what?
It was fun.
All right, if
It
this
was
is
awesome.
X, we'll call this time. So I said at 1 second, it was this far away. And at 2 seconds, it actually wasn't just this far away. Because if it were a constant velocity, it would be a straight line.
That'd be
At
space.
2 seconds, it would actually a little bit further like that. At 3 seconds, it was even further like that. If I connect these dots, oh snap!
It's that thing again.
That's why Mr. Dalton has been teaching us about this thing for like umpteen years.
It's that thing again.
It's a
Yay.
freaking parabola.
We're back to.
So I hate to say this, but like
Oh man.
I hate to say this, but like when I'm teaching Algebra 2 and I'm going through all of this stuff, and then my students raise their hand and be like, "Why the hell am I learning this?"
Yeah.
Right?
This is why.
I
I
say,
did this
well,
already."
well, because it's kind of it graphs this thing and then, dude, you learned parabolas for this, for physics.
We're
Oh.
now
In fact, it
using
was physics who made the parabolas, and then the mathematicians caught up. No,
All
I
right,
kid you
good.
not. These are all true stories. Like for
I'm
example,
ahead.
okay, so check this out.
But the chandelier wasn't true.
No, well, it actually is. It's kind of like a myth where like I'm not sure if it's
we can't
true.
prove it until we have time.
It's like Newton and his apple, right? Newton
Yeah.
got smart by getting hit in the head by an apple. No, that's not true. But I mean, a lot of people associate Newton with his apple, and it could very well be true. I just don't think
No one's there to
that's
prove
true.
it.
I don't know.
Yeah.
Or like Galileo and the Leaning Tower of Pisa, where he dropped cannonballs off the thing. You know, that could be a story, but it's actually maybe it's not. You know, I don't know. It's a myth,
There's no way to prove it.
so it could be true.
Yet.
You know, and actually they still do that. They have a festival every year when they drop a cannonball and I think it was
Pizza?
a cannonball and a something else. I forgot what, like a wooden ball or something like that.
I thought it was two
It
candy
hits at the
balls.
same time. Yeah,
So, I don't know.
but that was Galileo trying
It
to
was the
figure
whole
all of this
mass.
stuff out.
Yeah.
No. You know how like I was telling you, like physicists came up with it and mathematicians just caught up with it. Well, what's one of the most important things of math or subjects of math? Calculus. Okay, something you guys haven't covered.
Actually,
In fact, we are going to cover that in physics class.
thank goodness.
I will be I have a lesson that is
Purely.
called calculus.
Oh,
I was
sweet.
supposed to take that this year.
I'm going to show you guys
Loving
how freaking cool calculus
We were
is.
doing it
We're
together,
supposed
yeah.
to.
I'm going to show you guys what calculus is and how cool it is and how it actually applies to the world and why we even learn it. Okay,
Shoot.
so check this out. Here's the story that goes. Here's the story that happens is, and this is a true story, completely true. This I can say is true. Isaac Newton came up with physics. Okay, he came up with all of this stuff that I'm going to talk to you guys about.
Right.
And all we're going to spend this whole quarter. In fact, I probably won't spend any time with you covering anything else but what Newton came up with. Like I said, we're going to go through this slowly but deeper. He brought it out, and everybody said, "Dude."
You're
Well,
crazy.
They didn't say "dude," but they said, "Dude, none of this makes sense." And what Isaac Newton said, he said, "No, it does make sense. Here's the problem: is you guys just don't know the math." Like he brought out physics, and then they said, "Your physics doesn't make any sense with math." And then Isaac Newton came back and said, "No, your math just doesn't make sense. You don't understand that. So let me write this other book." So he went and worked on his workshop, and he wrote a book, and he printed it out, and it was like Principia Mathematica, and that was calculus. He invented calculus so that people could read it and
It's
understand
physics.
physics.
Okay, so I made this book, but now I need to make a book so you guys can learn how to read this book.
I made this whole wing of science, and now I have to make this whole wing of math so you can understand
Understand
my
my
wing of
science.
science.
I need to learn my math.
Don't worry, okay? So the math
jeez.
that I'm going the math that you need to know in physics for my physics is going to be a lot of algebra 2, a little bit of trigonometry, and I'm going to teach you all the trigonometry you need in order to survive.
Cool.
If you really want to get into it, if you want to see how it all comes together and how cool it is, I really highly recommend that you take calculus one day. And I'm going to show you how this applies to calculus and really what calculus is.
Yeah.
Because it's pretty freaking amazing. And I hate to say this, but like a lot of you guys are saying, "Well, I'll never be an engineer. I don't want to be an engineer. I want to be a business associate. I want to sell shoes, right? I want to sell hats."
Sounds lame.
And here's what I would say. Look, dude,
Sounds lame.
even though you want to sell hats and maybe you want to get a business degree, they won't require that you take physics, but what they will require is that you take calculus.
Really?
Yes,
Yeah,
it's called
it's-
business calculus.
Oh.
Yeah.
It's a whole class.
Darn
It's
it.
because it applies. So the stuff that I'm teaching you now is going to be applicable to your life.
Awesome.
The stuff that I'm showing you, no matter how crazy, how hard, I'll tell you what, I can't even say that's true for chemistry.
Because now we can not
Like
say
chemistry,
why am
the
I
stuff
learning
that I
this?
taught you, I'm kind of like, that was crazy, and I don't know if you'll ever use it again. I know that I tried to
Yes.
convince
Only
you
if
that
you
you
be a
would.
chemist.
I know that I spent all this time in convincing Bradley Bollinger, hey, you're
I
going to need this.
remember that.
But with physics, I really feel like I can honestly say that's the truth, and I'm not crossing my fingers. I'm
Physics
not
is the
lying to you
study
at
of
all.
the natural world.
What I'm trying to do with physics is I'm trying to teach you guys how to think correctly. I'm trying to teach you guys how to analyze things, how to understand math as it moves, as it flows, the ebb and flow of it.
Yeah.
It's actually really cool. And physics is kind of this way of it all coming together. Now, I'm going to tell you guys right off the bat that people find physics hard. This is the notorious, killer class. It's the hardest science of all, right?
Oh, yeah.
I mean,
Oh,
any
yeah, it's
high
no
school,
walking
you'll ask, which is the hardest one, biology, physics, or chemistry?
physics.
High school physics is killer.
Us comparing it to biology and chemistry, which are kind of
and it's almost one of those subjects where I'm so passionate about it. I actually wrote a textbook that I drew and interfaced it with comic books. In fact, it's right there, that white binder right there.
This one?
Yeah, it's up top, right there. No, you got it.
Oh, that one.
I wrote a textbook. I drew
my
comics for it.
God.
It's amazing. I'm so passionate about it. But here's the thing: is I'm gonna try to make this as easy as possible. And I'll tell you what, you're gonna have to work hard in this class.
Listen.
But
Okay.
it's an awesome topic.
Oh,
You're gonna find that math. Like, I think that some of my chemistry students were like, "Dude, I thought I was taking chemistry, but it turns out that I'm taking math." Well, physics is going to be a lot like that. In fact, that was the last semester was my first year teaching chemistry, and I probably taught it with way too much math because I'm a physicist.
Yeah.
I taught it to you guys like I'm a physicist. So, anyway, I wanted to introduce to you guys chemistry or physics. I want to talk about things. Oh, and here's another thing that I'm going to do. In fact, why don't we do it? Here's what I'm going to tell you I'm going to do in physics. I know you guys have a lot of homework.
all day.
In class, I'm going to go over homework problems.
Yes! Just
Before
like
they're
Algebra
due.
2.
Before they're due. More so than any other class that I've taught.
That's.
Yes!
I'm assuming we're gonna have like problems every day.
You guys have
Yeah,
problems
it's every
every
day.
day. Yeah,
Because it
It's
all
pretty rigorous.
bases on.
we're loaded, and the reason why I'm going over stuff is not because I think that homework is unimportant. It's kind of a motivation for you guys to come to class,
Yeah. You get
Right, like-
answers.
dude. I totally will come to your class now, right?
Yeah.
You give
And
me
then the
answers.
second thing is it's a motivation for you to watch my class, and then the second thing is it's also a chance for me to like get a kind of an idea of where you're at and that kind of stuff.
So like if we all have problems on the same problem.
Yeah. So I'll tell you what.
Yeah.
Why don't we go over two and then we'll be done with class. I'll go over two questions for you and we'll be done with class. All
Can
right.
we keep it? This is-
You want to check it out?
This
Yeah, you
is
can borrow. Why don't you
incredible.
borrow it? Because that was from 2010. I'm sure there's a lot like cooler things.
But I can't believe you made that.
I made that in college. Yeah.
That's incredible.
Yeah, it was
for a project, just for fun.
Okay, so here's what I did. All right, this is what we have. Is this physics textbook that I was always thought about publishing. I started it back in like 2003, and this is a labor of love. What I did was I took all the physics homework problems and I turned them into comic book problems.
Yeah.
And then what I did was I took all of those comic book problems and I animated it. And I actually wrote my own comic book. So this is my sister and this is my brother, and it's
Wow.
this whole story. And I think that I will probably give you guys a little bit of this stuff. A lot of the stuff I'm doing with you guys is coming from this stuff. But I think one of the things I'm starting to realize is that like I spent all my time doing this, and I spent a lot of the rest of my time like thinking about what students actually need to do to learn it. You know, so I'm trying to
That's
balance. I'm trying to balance those two worlds.
A textbook is always handy.
So, yes, you actually have a textbook. In fact, in this class, you have two textbooks. You have a conceptual physics textbook and a AP physics textbook. So you got the
Why don't I just take AP Physics?
because the
Maybe
conceptual physics is kind of your baby step into the chapter,
No.
and then we're going to get into the physics.
Yeah.
Right.
And then we'll go back to let's baby step into the chapter, and then we'll get hardcore again.
Dive head in.
Does that
Okay.
make sense?
Yeah, that's pretty sick.
So you have
Learn
to.
what you're doing before you do it.
Yeah. We're gonna learn. See what conceptual physics is the physics without math. You're sitting there thinking about what
Stuff.
will happen,
Oh.
and then so if once you get your brain corrected, where you can kind of think correctly about how things will happen, then we're actually going to calculate what happens.
Sweet.
Does that make
Cool,
sense?
Cool. Yeah.
All right. Anyway,
Think about
why don't we talk about two problems? And I don't know. I'm just coming up with questions. On your first homework assignment, let's see. Let's look at the second homework assignment. I'm just making. I'll just choose two
I
problems.
don't actually. I'm not registered in the class yet. Just
Yeah.
probably happened this weekend, so I don't have the homework up yet. I can't look at it with you.
An
I
object
can't
drop
either.
from rest.
He's just gonna tell him.
Oh, okay.
Yeah,
Okay.
it's-
Okay.
Oh yeah, okay, yeah. So write this down, and then when you get the chance to look at the homework, then you'd be like, "Oh yeah, that's the answer."
Yeah, it is a quiz, so you can't just peek.
An object is dropped. Oh yeah, and I think that I give you 4 chances.
I think it was 10.
Oh, I gave you 10 chances.
10?
10 chances
Whoa.
for all of your homework.
Yes.
So like, okay.
He expects
And
A.
I accept late homework. But here's the thing about my late homework policy. I accept late homework. If the date passed, still do it, okay? But I think around February 12th, that's going to be a date where I say, okay,
February 12th?
yeah.
Oh. So like, if you haven't done your homework in a month.
Yeah, I think around February 12th, I'm going to say, I'm going to close every single assignment before this date.
Okay, yeah.
And then you need to turn it in. You need to turn it in by then. After that, the computer shuts it off and it doesn't even allow you back in.
Yeah.
Sweet.
So there's going to be a few days, I think like 3 days this quarter where I'm going to do that. And I'll let you know way ahead of time when I'm doing that.
Okay.
So like, hey, you guys, like it's
Next
pretty
week.
much a week after the grade check, I'm going to turn off the assignments.
Then we can also go back and redo it if
Yeah, you can do it
understanding.
Before that point, you can go and
Go back
take
whenever.
it 10
Whenever
times
you-
apparently.
Yeah.
But after that date, I need to start closing things down. So
Yeah.
that is something where I'm going to have actual like these are hardcore. Like I do give you due dates, but they're kind of recommended.
Yeah.
Whereas those ones are just like it's done. Because the reason for that is because at some point I don't want you guys to just push all of your homework until the last day. Because then you're just going to drown and you guys are going to be all upset at me and all upset at yourselves. And that kind of stuff. I hate this class. It's not the class's fault. It's your fault for, dilly-dallying the whole time. All right, anyway, we haven't even talked about this stuff. All right.
Yeah.
An object dropped from rest falls freely. After 7 seconds, calculate its instantaneous speed. Okay. So I take something. I drop it from rest. Let's write down things we know. What is its V naught?
0.
0. Because I dropped it from
0.
0.
rest.
Yeah.
It falls. It's going to change its speed, isn't it?
Yes. From gravity.
Because of what?
Gravity.
Gravity. So is V final going to be the same as V initial? No.
Mm.
If it weren't acceleration, then V final would be the same as V initial.
Yes.
But then again, if it started at V0 and it weren't accelerating,
It's still be 0.
it's still going to be
Yeah.
V0.
It's just going to be sitting there.
But it did,
Yeah.
so it's not B0.
Ooh, wow, look, it's interesting. All right. The equation that I can think of is acceleration is delta V over
T.
delta T.
Yeah.
And the acceleration that we're talking about is G, so I'm going to change that to a G. Is that all right with you guys?
Yeah, gravity.
All right.
Got it.
Actually,
Yo.
is this recorded?
Yeah, this is recording.
Can I look at it tonight?
Sure.
'Cause my bus comes in like 2 minutes.
All right, go. Get out of here.
Coolio. Hey, I look so forward to this.
I'm stoked too.
This whole
This
semester
delta
is awesome.
V is V
See what-
final
see what-
minus V
Yeah.
initial.
Right.
And this delta T is actually T final minus T initial. Okay? V initial in this particular case is 0. So really V final minus V initial or V final minus 0 is really just V final. We cool with that?
Yeah.
The same goes for T.
That's just
Here's the thing, and I'm going to actually backtrack and show you guys something kind of cool. Oh, close the door. Close the back door.
Alright, later guys.
See you. Alright, here's the thing. You notice how, remember when I wrote A is equal to delta V over delta T? I almost never write delta T. I just write T. And I'll tell you why. It's because if this were 0, which in this case it is, the time initial is 0, then really I just have T final on the bottom, right?
Yeah.
And I almost always set up my problems so that time initial is 0, right?
Right.
Like when I say, okay, we're going to start the experiment, go. When I say go and I press the button, it didn't already have like 3 seconds on there.
Sorry, from 0.
We started the clock at 0, right? So you'll never see me write A is equal to delta V over delta T. You'll pretty much always see me write A is equal to delta V over T.
Cool.
It's not to say that that delta V is, or that delta T isn't there. That's just assuming that I started my stopwatch at 0. We cool?
Yep.
Did I lose anybody yet? No. All right, fine. I'm gonna get V final all by itself. How do I do that? V final is not all by itself because of that t.
Right.
How do I get rid of that t? This is where algebra really comes into play. What is t doing to the V final?
Being divided by the V final.
Dividing. Good. Okay, good. So what can I do to get rid of it? What's the opposite of dividing?
Multiply.
Multiply. There we go. I'll multiply that by t. But what I tell my son is I say, well, what do you do? Well, you always have to play fair, right?
Right.
So if you multiply that side by t, you better multiply that side by t.
Right.
Very good. So that t cancels out with that t, and you end up getting gt is equal to v final. I could have written tg. It's the same thing.
Okay, cool.
Okay, so v final is what we're looking for, and we have that. Or, I mean, that's what we solved for. T was 7 seconds, and g, in this case, I'm going to say use g equal to 10. I know I told you it was 9.81,
But they
but I think
rounded.
for Paul Hewitt, he just told you it's 10.
He
For
just
conceptual
rounded it
physics, you're like, it's just 10.
up.
So v final is equal to 10 meters per second squared times 7 seconds. Now, what is the number? You guys know this. What's the number? 10 times 7. 70. But here's the thing, and remember how I told you guys, hey, units are going to come into big play here.
Right.
Watch, check this out. This is meters per second squared. There are 2 seconds on the bottom. Not 2 seconds, but like a second and
Yeah.
a second on the bottom.
It's squared.
There's 1 second on top.
70 meters per second?
Do you notice that? So one of these seconds on top can cancel out with one of these seconds on the bottom.
Oh, right.
So your answer is 70 meters per second as far as the units go. But the beautiful thing is, the units told us it was meters per second. What are we measuring here?
Velocity?
A velocity which has units of
Meters per second. Oh,
awesome. So here's what my point is. You know, remember how I told you units are going to come into big play? Units is actually like this gift that physics gives you. Because what it does is it allows you to check your work. You can immediately go through it and say, oh, I totally got the right answer.
oh.
All of my units worked out. Or you can go through it, and here's my favorite part, is when it doesn't work, and you're like, oh, snap, I screwed up. And then you go back and you find where you messed up. That happened to me all the time. Units is going to be one of your best friends. Or your biggest enemies, I don't know. Depending on how you want to look at it. Anyway, that's answered, 70. Any questions? Is this too hard?
No,
Easy?
that was cool.
You know what? I'm all out of time. I guess I'll have to do another problem with you guys later.
Cool.
But thank you for coming, and I hope to hang with you guys soon. All right. So I won't see you this Monday, but next week Wednesday we're gonna have a lab, and I'm gonna figure out exactly what kind of lab we're gonna be doing. It's gonna be an awesome lab, I'll tell you that. All right. Archive is stopping, and I'll see you guys later.